Okay. So the summary for this session is that we will go over, recall again what is the K-mean clustering, so that we know the differences between the previous lecture, is the K-means clustering, and also the density-based clustering. So we are trying to make comparison of these two methods that available for cluster analysis. Okay, and we will go over some of the important aspect of DB scan. So we look at the point, we look at the optimal radius of the cluster, and also we look at the minimum number of points in the cluster. We look at the algorithm secara general, and then the disadvantage and complexity. So if we recall back, what is the K-mean clustering? So we look at the uh, K, given K, the K-means algorithm is implemented to form K number of cluster. So what happened is that we will partition the object into K non-empty subset. Non-empty subset referring that we cannot have empty cluster. Okay, so this is K number of cluster. So how do we perform the K-means clustering? That we will look at the center, we will randomly pick the center of the cluster, then we assign the remaining point to the nearest centroid. Okay, so we will assign each object to the cluster with the nearest seed point ataupun center. So we'll go back to the second step to recompute the new center. Then we will redo again reassigning until there are no changes of center. So for example, like this, if we have k equal to 2, red one is randomly picked. Okay, so we'll have this cluster. So we have 1 and 2. So once we get this cluster, we have to update to the new center here. So the new center from here move to here. So basically it moved to here. Okay, and then from here to here. So depending on the result of your first stage of clustering. So once again, once you get the new center here, then they will assign the remaining member to the nearest center. So so we have this one. So we will continue again, and so on, so on, so on, and so on. So our final ni will be this one. So basically in the K-mean clustering, we tell them how many number of cluster, and they will randomly pick the center of the cluster. Then they assign all the remaining member to the nearest center, and we repeat and so on. So this was the example last time, when we have this the first three center, and they assign the remaining number to the nearest one, and then they keep updating the center until there are no changes. Then we get this as the final one. Okay. The problem with the K-mean clustering is that we need to specify the value of K, and also they are very sensitive to the outlier, since an object with extremely large value may divert the center of the cluster. So To solve this, we look at the midpoints. So instead of taking the mean value of the object in the cluster, we look at the midpoints, which is the most centrally located object in the cluster. For example, like this, if we have these two clusters, we look at the midpoints. But this still need to tell what is K. So they introduce a new one. So a new one is basically density-based clustering. So for this one, you don't have to tell what is K. So basically, all the points that are located near to each other will be grouped as one cluster. So depending on the situation. So the major feature for this is that they discover cluster of arbitrary shape handle noise. So which means that all the outlier will not be included, and then all the points that are located nearer to each other will be considered as one cluster. So it goes one scan only. So compared to this, we have to, walaupun we have performed the clustering here, tapi we update the new center here, so we need to perform one more time again, and then until we reach this stage. So this one is 6 times scanning, okay, and 5 times changing the center. Okay, but for this one, we only need to do one scan only. So that depends on the density parameter to do the termination condition, meaning that we stop the algorithm lah. So for density-based clustering, they can perform any shape of cluster. So even in this, and this is non-spherical. So this is spherical. This is a mix of spherical and non-spherical. Okay, so the cluster based on density, such as density connected point. So we are looking at how close they are. So before we can go further, we need to look at some of the definition. So we look at the definition for density, because the dB scan is stand for density based scanning. Okay, so we look at the density. So when we mention about the density, basically we are looking at the number of points within a specified radius R. Okay. So in short, we are looking at the EPS, which is the specified radius R. So this is the distance, the radius of the circle that we have, or the cluster that we have. Okay. For example, we have this cluster, so the radius will be this one. Okay. And also the point is a co-point if it has more than a specified number of points, minimum points within this radius. Okay, so for example, let me show you here. So this is a co-point because our minimum point will be 4, meaning that if we have nearest neighbor 4 at least, then within the radius range, so this is your radius range. So we have 1, 2, 3, 4, 5. So that is, this point will be considered as the core point. Okay. And we also have what we call it border point. So the border point is a member of this, but they have less than 4. So the definition here is a border point has fewer than minimum number of point within the EPS, but is in the neighborhood of the core point. Okay, so this is in the neighborhood of the core point, have less than 4 number. Okay, less than 4. So this is what we call the border point. If you have any other than that, so for example like this is considered noise. They have less number of in point, and they are far away, including in the radius. Okay? So for this one, this is noise. Noise 2, yeah, because they are not within the range of the radius and they are not filling the minimum point here. Okay? The minimum point is 4. So how did they perform the clustering is that they will scan one point at one time, and they will analyze given the radius and given the minimum point, they will determine whether that is a core point or not. So the two parameter that is important is that the maximum radius of the neighborhood and also the minimum point. So the minimum number of point in the app's neighborhood, so within this radius. So we mentioned that this is the notation for the P. Okay. So if Q belong to cluster, no, Q belong to the cluster such that the distance between the P and the Q will be less than the radius. Okay, so meaning that Q belong to this particular cluster if distance between the Q to the P is less than the radius. We also have this directly density reachable. Point P is directly density reachable from point Q with respect to this range, and also with respect to the minimum point if P belong to this cluster, and the core point condition is that the distance, the number of this cluster is greater than the minimum point here. Okay, so let me describe what does it means. Okay, so well, looking at the directly density reachable. Okay, let's look at this P. This is core. This is core, yeah, because based on our example, minimum number of points will be 4. So that we have 1, 2, 3. So this is P, and we also have this one. So this is also core. Why? Because if you look at the radius here, so I have 1, 2, 3, 4. So within the range here. And then we look at here again and so on and so on. So this also core. Let me erase that one. Did too many. So this one is also core. Okay, this Q, no, this Q is also dense or the core because within the radius here they have more than four number. Okay, so we say that a point P is density reachable from a point called point Q if there is a chain of point P1 up to Pn, where this is your P1 and uh, this is your Pn. So you have a series of this example. This is P1, Q, and this is P2. Yeah, and this is P3. So we say that this is directly density reachable to that, meaning that this is one cluster already. So similar to this, this point, so you can go over here or over that side because every time, okay, let's suppose we say this is the core. When we are here, this is also core because it has a member of more than 4. So if we go here, again, it has more than 4 member here. Okay, so all of this will be considered as one cluster. It goes to one item at one time and look at the surrounding. Okay, so all the core point will be connected and they form the cluster. If you look at the real one, so this is how they form the cluster based on the density reachable. So they will connect to each other until they stop. Okay, so that is the first cluster. This is the second cluster. The black one is the outlier. So remember that for this one, they just scan one time only, meaning that each point will be scanned, whether they belong to the cluster or not. So how do they know that this belong to the cluster? They look at the density. So the DB scan has the advantage here because we do not have to specify K. And also it will be able to cluster untuk yang bulat kah atau round kah, so non-spherical form. Okay. So the idea is they group all the items that have same density as the previous one that you have scanned. So you can do all this. If you use the k-means, you will not have the cluster like this. And the issue that we want to address in DB scan is what is the best radius number. Okay, so for example, like this, we look at the average distance and k equal to 4. So the average distance will be here. So we look at the distance once the plotting is going up like that, then we say, okay, the breaking point is here. Before the distance become high, because we want to have low distance here. Before breaking into high distance, so we consider this is the best radius. Okay, so if we look at the formal for the code or the formal step-by-step of DB-scan, we start with the cluster count to be 0. And for every point that we have, okay, so for every P is not a core point, we assign a null label to it. So, meaning that they are not the core. If P is a core point, a new cluster is formed. Then we say that we update this one to cluster count plus 1. Okay, so how do we know that P is a core point? As long as they have what? The minimum number of points within the specified radius. And once I get the core point, then I will find all point density reachable from P and classify them in the cluster. So I'll be joining the rest of the item if they are density reachable. So based on the illustration just now, keep connecting all the that is reachable from the core point. So we repeat the process until all of the points have been visited, or one scan only. So one of the flaw for this one is that if you have different density, you won't be able to cluster them. Okay, for example, like this, you won't be able to cluster this. Okay, and for high dimensional data, so high dimensional data meaning that you have few number of columns. Or when you have few number of columns, then you will have you will not be able to cluster all this. Only this high density one. Still better than k-means. Okay, so the time complexity will be. You don't have to worry about this. This is just look at the complexity. So the n here referring to, because we are looking at one time only scanning. So the complexity will be one time only, number of sample. Okay, so don't worry about this. So now let me walk you through how do we use R in how do we use DB-scan in R. Okay, so let's use this data set. Okay, so we're loading this data set, then we look at the structure. So the structure has 5 variables, 150 object. Then we install this one, FPC fixed point clustering. And then we load this package. Okay. Then this is just data cleaning. So meaning that we will remove the 5th column. Initially we have this, but we don't need this one because we only need the first 4. So we remove this one. So how do we perform that one? We just put iris -5. So meaning that we remove the column. Okay, now how do we use the DB-scan? So the DB-scan here is this command. Then we use this data. We clean. Okay, this is the data that we clean. And then we specify, okay, this is the minimum radius, and this is the minimum number of points for that cluster. Okay, so the result will be stored here. Then when you want to see the result, you just retype the name and you get this. You have 150 points, and then this is the minimum number of points for the core point, and this is the minimum radius on the maximum radius. Okay, so what we have is that we will have 3 clusters here. Okay, 1, 2, 3. So this is the core point. So this is the border that belong to that particular cluster also. So this one tell you the number of member of each cluster. So the good thing about this, you don't have to specify K. It will scan through your data, and it will tell you how many number of cluster is the best one. Okay, and if you want to get the membership of the cluster, so you just put uh, the $sign and cluster, so it will tell you all this membership of the cluster. If you want to look at the how good is the clustering, so if you use this command to label the cluster and also the iris species, so this is the cluster ID. This is the type of the iris. So we look at this one, okay. So this one should be grouped together because they belong to Satosa. But two of them belong to cluster 0. Majority of them belong to cluster 1. So that's fine. For the color, it's supposed to be in one cluster, tapi this one, 43 of them belong to cluster 2 and 7 only belong to cluster 0. So that's fine because majority of them belong to 43. Okay. So for the last one, Jenica, so 35 of them belong to cluster 2 and 15 of them belong to cluster 0. So there's a big difference between the cluster result and also the type. Because they're supposed to be belong to one type, is the Jenica, but they are split into cluster 0 and 2. So this is just to look at the how good they are. Okay. So if we look at the distribution of the data based on the cluster, so we could type this one. This one, example, this one we look at the sepal width and also the sepal length. So how they are distributed here, which is nice. So we look at here again. So this is between the petal length and also the petal width. Okay, so we can do any analysis here. So this is just based on the plotting of the two variable. We have 4. So we can have how many analysis here. Okay, so the color tell you cluster and plotting tell you whether they are value of the petal width and also the petal length distributed among the cluster. Okay, let's take a look at the second example. Okay, so in the second example, we use this data set. Okay, the data set, let me show you. So this is the top data set that we have. So we have the round one, the green, the yellow one, and then the big round, the blue one. We have this, and then we have this, and so on. So basically, we have 5 clusters here. If you use DB scan, it will automatically tell you, okay, we have 5 clusters. So what happened here, we get the data from here, then we load the library, we install all this, and we upload this. Okay. So this is how we load the data. We get the data from this package where we install here. Then if we look at the data that we have X and Y. So basically, we get the data from here, and then we focus on column 1 and 2. And we put in here, df. Okay, so this is our data. Now, how do we use the DB scan? So we say, okay, I will use the DB scan from this package. And then this is my data, and this is my maximum radius, and this is my minimum number of points. So it will give you the same result here. Okay? But this time it give you six number of cluster. So basically 6, yeah. 0. 0 is not here. Okay. Yeah, because we do not have the core here. So we have 5 cluster only. So these are all the membership. And then when we plot them, we plot this DB, okay? And we use the data here and the stand here. Stand here referring to, let me check. Okay, the stand here referring to if this is true, data is standardized before we use the PCA, or they are normalized. Let me update this screen. Okay, so in this one we have the geometry here tell you whether we show this one whether we show the center or not. So this is false, meaning that we will not show the center. Because for example, like the blue one, it's better just to show the membership of the cluster only. And shapes means we will do clustering of different shape, okay, and we will only plot the point. And the classic for the ggplot will be standard one, the classic one. The palette, let me get back to you, but this is some of the setting that we use in order to plot different color. So if you look at the differences between k-means and dbscan, the dbscan allow you to perform the clustering without worrying about the number of cluster. So, for example, like this, we only have 5 because in this one we do not have core. Okay, they are not the, meaning that they are outlier. If we go back to the previous result here, so this one, so basically we only have 2 cluster here. Cluster. That means this is not a cluster. They belong to borderline. So any question? Okay, all the step here we can repeat. There is no error, so you just follow through this one. Follow exactly the statement here for you to follow. Any question? Any question? So for this one, I let you do the practical. What time is our tomorrow? Practical. Tomorrow our practical.